We've announced tons of new features recently, and while this latest announcement isn't a new feature exactly, it's still one of the things that our customers tell us they care about most: the ability to detect more uplifts with greater confidence. We don't just help our customers run individual SEO tests, we help them design entire experimentation programs. As they do that, they know they will identify some winning tests, some losing tests, and some inconclusive tests. All of these are actually important parts of an experimentation program. Losing tests highlight things to avoid, enabling you to stay ahead of the competition who can't avoid those drops. And sometimes they point the way to future winners. And identifying hypotheses that don't result in measurable impacts helps with efficiency, resulting in you asking your product and engineering teams to maintain only those features that actually help with meaningful results. But despite all of that, we know that what everyone really wants is more winning tests. Every time you click launch on a test, everyone is hoping it's going to be a winner. Not only is that human nature, but it's also the source of the biggest and most concrete business impacts. So we know that anything we can do to get more winners, get greater statistical confidence, and identify even small uplifts within the bounds of statistical significance is going to be work that pays off for our customers. And this isn't new. We've been working on it as long as we've been running SEO tests. In fact, you can go back to August 2019 and see an announcement that we were moving away from causal impact, which was the industry standard open source tool, towards a neural network model that was twice as sensitive, allowing us to identify uplifts half the size we could before. Improving even further has been a major focus of our research and development efforts, and the exciting thing that I'm here today to tell you about is that we've made some breakthroughs. We've improved the way we train our models with two new approaches: a local optimizer that focuses on bucketing splits that are similar to the real-world split, and a global optimizer that seeks the very best buckets it can find to use as training data. I'm not going to get into the details of the mathematics and statistics here today, but let's look at what it means on a real test. This test is not significant at the 95% confidence level. It's borderline at 90% confidence, which is this narrow bar here. This is exactly the kind of test where we'd love to know the real truth. Is this predicted uplift real or not? Our two new models get progressively better bottom ends of their confidence ranges, showing clear 90 and 95% confidence intervals. This is what we mean by better models. The midpoint of the range typically barely changes, but the confidence intervals grow tighter, enabling more tests to be declared statistically significant. But looking at one test doesn't tell us a great deal. Let's flip to some benchmarking data. We ran our previous best model over a particular representative sample of real old tests, and found 13% of them showing statistical significance. Now, that local optimizer that I talked about gets to 18 or 19% of tests at 95% confidence. The global optimizer gets to 24%. And from there, we threw more compute power at it and ran a much larger search for the best performing samples to train the model on. We call this Global 10, and it managed to get to statistical confidence on almost 29% of the tests in the sample, more than double our best existing model. As I said at the outset, getting more winners is most of our customers' top priority, and we attack that problem in a variety of ways, including helping them run more ambitious tests more easily, gathering additional data from Googlebot crawls and Google Search Console and more. But statistical breakthroughs like this are one of our most powerful tools, and so we're looking forward to bringing this increased power and greater win rate to all our customer accounts.